We've looked at taking an equation, a function, and from that building these sine waves. Now we're going to go backwards. We're going to take a bunch of data, a bunch of points. Essentially, we're going to take a sine wave, and we're going to come up with an equation that represents it. So we have this data from Cape Town, South Africa, I think it was. Average monthly temperature, and we have this plot over 2 years. We want to create a model, an equation that will do a good job of representing this data. And we can see that this is sinusoidal. It is definitely periodic. It goes up and down. It oscillates. So what we have to do is we have to think about the 4 key features of these sine graphs. We had amplitude. We had period. We had phase shift. And we had vertical shift. We could take those out of an equation and put them on a graph. Now we're going to take them off the graph and put them into an equation. So let's start with, I don't know, what's the highest that this gets? What's the biggest data value that we have here? Looks like it's 28. And the minimum data value, it looks like, is 15. Okay, so how does that help us? What do we care? If we subtract that, that's our range. That's the distance between the highest and the lowest. This is the high point. This is the low point. So subtracting those, we get 13. So what does that do for us? Well, what that does for us is we can divide that in half and get the amplitude, can't we? So our amplitude is 6.5. Now, where is that amplitude measured from? That amplitude is measured from the midline, which matches up with a vertical shift. And the way we can get that midline is we can take the 28 and the 15 and add them and divide by 2. And what we get is, it's actually our 15 plus 6.5, 21.5. Guess what? That's our vertical shift. And we have our amplitude, 6.5. We are halfway there, ladies and gentlemen. So, let me put a couple lines on this graph. We had our maximum right here. We've got our minimum right there. Our midline is that line which our wave is going to oscillate about. That's right here. We found our amplitude was there and there. How about period? Well, period is the length of one cycle, remember. So let's go there to there. Well, that's 12 months. But remember, we don't just put that into the equation. Our equation was a sine b x minus c plus d. Remember, we don't just plug 12 right into this equation. We got to do this 2 pi over b thing. So we're going to take this now and we're going to solve for b. So 12b equals 2 pi, and we get b equals pi over 6. Awesome. Now there's a few different ways we can do this last part. The last part of this is phase shift. I got this period stuff written in the wrong spot. That should be period. And so we took that period, and that allowed us to find b, part of our equation. Now I have to decide where the sine wave is going to start. And there's lots of different ways that we can do this. There's infinitely many correct equations that we can use. I'm going to pick a cycle where it's starting out on the midline and cycling up. That looks right here at A. Right there, that looks like a good starting point because the wave goes up, down, and back up again. What is our shift? How far have we shifted? Well, we've shifted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's our phase shift. So our equation, y equals amplitude 6.5. If I picked one of these waves starting out going down, I would have put negative 6.5 here. Sine b is pi over 6. Suppose instead of y I should use capital T, since that's how my variable is labeled here. Then little t for time minus 10, phase shift, plus 21.5. And there's my equation. This is one of infinitely many equations that we could have gotten. We could have gotten an equation involving cosine if we really wanted to. It's usually the case that you're going to be writing equations involving sine.